Hi friends, today we are starting second chapter part C, that is show that total energy is conserved for freely falling body. This is the big derivation important. Show that total energy is conserved in freely falling body. Now here, this is the body when it is at on the surface of Earth. This is the body when it is at highest point. This is in between point, not necessarily it is middle, but this is point C. Now you have to describe this part. Consider a body of mass m is initially at point A, where it possesses only potential energy. When it is dropped from that height, it possesses both potential as well as kinetic. But as it is going down, potential energy will decrease and kinetic energy will increase. So when the body is at point A, it possesses only potential energy, which is mgh. Since kinetic energy is zero because body is at rest. So at point B, say initially displacement will be what h. From A to B, displacement will be what x. So remaining height will be what h minus x, this one. Now when the body is at point B, it possesses both u is equal to mg, this is h minus x. Kinetic energy will be what mgx, right? When the body is at point C, it possesses only kinetic energy, potential energy will be what zero. Kinetic energy will be mgh. We have to prove this part, this as well as this one, right? For that I'm doing the derivation. So right here at point A, as body is at rest, so right here kinetic energy will be zero. So only energy possessed is potential, which is equal to mgh. So can I say total energy is equal to what? Kinetic plus potential. But kinetic is how much? Zero plus what? mgh. So total energy over here is what? mgh. This is the total energy. Now at point B. At point B, what is the height? Only this is the height. So potential energy will be, this is mg, height is h minus x. Now I want to find what is the velocity at this point. For that I have to use kinematical equation. And third equation, that is v square equal to u square plus 2as. Now over here u is equal to 0 because body is dropped from A, so initially it is at rest. V is equal to v1. Your A is equal to g because freely falling, it is acceleration due to gravity, and your displacement s is equal to what? X. Only this is the displacement, right? So right here this is v1 square is equal to 0 plus 2g x. So can you write here v1 square is 2gx. So kinetic energy k is half m v1 square, which is equal to, this is half m. v1 square is nothing but what? 2gx. So this 2 cancel. This is only mgx, right? So this is the mgx one. Now what is total energy? It is equal to kinetic plus potential. Kinetic is what? mgx plus potential is what? mg. Bracket में it is what? h minus x. I will open this bracket and then I will get total energy is what? mgx plus mgh minus mgx. mgx cancel. So total energy is equal to what? mgh. This is about the part B. At point C, this is point B. At point C. At point C, what is that? Your height is 0. So your potential energy, so right here it says h is equal to 0. Your potential energy कितना हो जाएगा? 0. So only energy possessed is kinetic. Now what is the velocity over here? For that again I have to use the same process. Since we write v square equal to u square plus 2as. Now body is not dropped from here, it is again dropped from A, because suppose this part is not there. So right here u is equal to 0. Your v is equal to v2 because velocity is different at different point. Right? A is equal to freely falling is the free fall, acceleration is acceleration due to gravity, displacement is the total height. So right here this is v2 square is equal to 0 plus 2gh, right? So you can write v2 square is equal to 2gh. So kinetic energy K is half m v2 square, right? This is equal to half m v2 square is 2gh. 2 to cancel, it is kinetic energy is only mgh, right? So can I write therefore total energy is equal to what? K plus u. Now K is only mgh, u is 0. So total energy is what? Mgh. So from this we can show that total energy is conserved, which is same to off. That's it about this derivation. This is they can ask for derivation for 4 marks. Now if they ask this derivation, you should write the law of conservation energy. That energy can neither be created nor be destroyed, but can be transformed from one form to another, and total energy of system remains same. That statement you should include. Now there is a one question of 2 mark, that is a graphical representation of total energy against height. Now here they can ask what is the graphical representation of total energy against the height. Now the graphical representation says this is your height, right, which is h. This is your total energy. Graph is something like this. This is the one part, and second part will be like this, right? Now this is what is your total energy. This is your kinetic energy. This highest point is your h, right? Your h. This is your h by 2. This is 0. This total energy is over your mgh. This will be what? Mgh upon 2. This is about the 2 marks part. They can ask this total energy against height graphical representation. Now next part will be oscillating pendulum. Oscillating pendulum. This is the rigid support. So I write here this is rigid support. To this rigid support, this is a bob attached, right? Now in book text notebook you have these 2 lines. So I will select this line over here. I will select this line over here. So there will be no mistake from your side. Then I will take the oscillating part. It will go like this, right? So over here it possesses what? Only potential energy is equal to 0. Kinetic energy will be what? Mgh. So total energy will be what? Mgh. Over here, what is the height? H is the height. So potential energy U is equal to mgh. Kinetic energy will be 0. So total energy is what? Mgh. Same part we write here. U is equal to what? Mgh. Kinetic energy will be 0. So total energy is what? Mgh. So they can ask this oscillating pendulum diagram for 3 marks, and along with that we have to discuss. Okay, when the bob is at extreme position, it possesses only potential energy. When it is released, it possesses both potential as well as what? Kinetic. When it is at lowest point, it possesses only kinetic energy because potential energy will be 0 at that point. Now, in this part, there are only 6 numericals in this part. Out of that, I am doing only last 3 numericals. They are the difficult numericals from this chapter. Now, I am talking about now 4th numerical. Now, in this video only I am doing this numerical because it is very short video. 4th numerical says this kind of structure is given. Your height is given. Your height is given. So your h1 is given as how much? 75 meter. Your h2 is given as what? 15 meter. Right? Now weight of a sphere is given. That is weight is how much? Is 60 kgf. So I will write mass is equal to what? 60 kg. Right? What they want here, calculate the change in gravitational potential energy. G value is given. It is 10 meter per second. Now change in potential energy, A part, delta U is equal to U1 minus U2 because H1 bada, which is U1 minus U2. So I will write this is mg H1 minus what mg H2. So mg common, this is H1 minus H2. If you substitute the value of mass as 60, G as what 10, 75 minus 10, this comes out to be 36,000 joule. This is how much? 36,000 joule. Now in B part, what they are asked in B part? They say 75. If 75% of energy in part A becomes kinetic, so right here, since 75% of delta U becomes kinetic, so I can write 75 by 100 of 36,000 is equal to what? Half mv square. So if you cancel this part and if you substitute the value, this comes out to be v square is equal to, it comes out to be what? 900. So v comes out to be 30 meter per second. That's it about the fourth numerical, right? Now fifth numerical. What is given in the fifth numerical? In fifth, what is given? Hydroelectric power station takes its water from a lake whose water level is at a height. This H is given. Kitna? It is 50 meter, right? Above the turbine, assuming overall efficiency. Efficiency is given as what? 40%. One more thing, what is power output? Then power output is given as 1 megawatt, which is 10 raised to 6 watt in each second. T is equal to 1 second. What they want? Power. What they want is the mass. Now check. What is efficiency? It is equal to power output upon power input. This efficiency is 40%. So 40 by 100. Power output is what? 10 raised to 6 watt. Can I write power input as work input upon time? So this is power output as it is. Power input is what? Work input upon time. But work input is nothing but mgh upon t in each second. T is 1 second. So this is 40 by 100. Right? This is 10 raised to 6. I am writing as 1000 into 10 raised to 3. Mass पता नहीं, g का value 10, h कितना है 50, right? If you solve this part, this comes out to be mass is 5,000 kg. This is about calculation. Now this is again important sum. This part is very important. Conversion. Check with the sixth sum. What is sixth sum says? The bob of a simple pendulum is imparted a velocity of 5 meter per second. Now, what is given there? Since 60% of energy is lost against friction. So, can I write here 40% of kinetic energy is potential? So, it is 40 by 100 of half mv square is equal to what? Mgh, mm cancel. So this is 40, this is 4 by 10 into half into big is 9. It is given as what? 5 square, right? Is equal to g ka value 10, h ka value they want h. So if you solve this comes out to be 0.5 meter. Now friends, that's it for this video. We'll do remaining chapters maybe in the coming week. Thank you.